Section 3.3, solving systems of linear equations by elimination, also known as the addition method. So first thing, make sure the system of equations are in the standard form, so in the form of ax plus by equal to c. Make sure all of the coefficients are whole numbers. Multiply one or both equations to make opposite coefficients for one of the variables. Add the equations and solve. Then you're going to apply substitution with the solution into one of the original equations and solve for the remaining variable. So how does that look? So when we look at example 1, we have 3x minus 4y equal 2 and 4x plus y equal 9. So you want to look for a plus minus situation. So when I look at here, 3 and 4, they're not plus minus, they're both positive. Negative 4y and positive y. Negative and positive situation. So if I multiply the second equation by 4, I can eliminate my y's. So what we're going to do is put parentheses around the second one, 4 on the outside. You are bringing the first equation over and we're still 3x minus 4y equal to 2. We are multiplying in, by distributive property, 4. So 4 times 4, 4 times y, 4 times 9. So we become 16x, positive 4y equaling 36. Now we're going to add straight down. So 3x and 16x make it 19x. Negative 4 and positive 4 cancel out, equaling 2 and 36 is 38. So now we see 19x equals 38. Divide both sides by 19. So x equals 2. Now we know what x is. Pick one of your originals. Since the second equation had 4x plus y equal 9, that's what I'm going to go with. So I'm going to write 4x plus y equaled 9. We are substituting in 2 for the x. So 4 times the parentheses 2 plus y equaled 9. We get 8 plus y equals 9. Subtract your 8 over. So we get y equal to 1. So your ordered pair is 2, 1. And because we had an ordered pair, we know we are one solution. We are independent because we would have 2 graph lines. We are consistent because there's a point of intersection. Example 2 says 4x plus 5y equal to 2. 3x equals 1 minus 4y. So the first thing I notice is the first one is in standard form, the second one is not. So we're going to change the second one to standard form. So I'm going to add 4y back. So we become 3x plus 4y equal to 1. So I'm going to write my two equations now in standard form. 4x plus 5y equal to 2. And the new standard form one is just 3x plus 4y equal to 1. So now we look at our numbers. 4 and 3, both positive, different coefficients. 5 and 4, both positive, different coefficients. So we need to figure out which one we want to change, and it's your choice. So I always look for the smaller multiples. 4 times 3 is 12, 5 times 4 is 20. So 12 is smaller than 20. I'm going to change them to 12s, positive and negative 12. So we're changing both equations. The first one I'm going to multiply by positive 3, and the second one by negative 4. That way you have your plus minus situation. So I'm going to apply distributive property. So we get positive 12x, positive 15y, positive 6. You're multiplying by now negative 4. So we get negative 12x, negative 16y, negative 4. So we've changed our equations. Now we're going to combine like terms. Positive 12 and negative 12 cancels. Had $15, spent 16. I'm short 1y. Had 6, spent 4. I have $2. You're not allowed to have a negative variable, so divide both sides by negative 1. So y is negative 2. Now we know what y is. So pick one of your originals to solve for. So I'm going to go with the second equation that said 3x equals. So I'm going to write my equation. 3x equals 1 minus 4y. And in place of y, I'm going to plug in negative 2. So I have 3x equals 1 minus 4 times the parentheses, negative 2. We have 3x equals 1. Negative and negative makes it positive 8. Add your terms, you get 9, and then divide by 3, so x equals 3. So we have an ordered pair of positive 3, negative 2. Again, because it's a solution point, we have one solution. It's independent. It's consistent. Okay, when we look at example 3, it says x minus 2y equals 6 plus y. The second one says decimal 0.05y equaling 0.02x minus 0.10. So we have whole numbers in the first one, decimals in the second one. There's y's on both sides of the equal sign. So first thing we're going to do, we're going to move our y back to make it standard form. And I'm going to multiply, since it's 2 decimal places for all of them, multiply by 100 to get rid of your decimals. So we're going to subtract the y back. So we become x minus 3y equal to 6. When we look at our second equation, we are going to multiply by 100. So we become 5y equals 2x minus 10. Whole numbers, which now if we subtract our 2x back to standard form, our second equation becomes negative 2x, positive 5y equaling negative 10. So we have two equations, two unknowns. Notice that there's a plus minus situation here with x and negative 2, and there's one here with negative 3y and positive 5y. But if I only have to change one equation here. So I'm going to multiply the first one by 2. So we become positive 2x, negative 6y, equaling 12. I lined it up right underneath this second equation. Reason being, since we only had to change one, I can see the negative and positive x's cancel. Positive 5, negative 6 is negative 1y. Negative 10 and 12 is positive 2. Divide both sides by negative 1. Y equals negative 2. So, and then we pick one of your originals. So I'm going to go back into the first one, which we left here as x minus 3y equal to 6. X minus 3y equal to 6 because it's still the original problem. I just have it set up in standard form. So we have x minus 3 times negative 2 equaling 6. X plus 6 actually equals 6. Subtract 6 over. It doesn't go away. X is still equal to 0. So we have a point at 0, negative 2. Now, in this one, because it's 0, negative 2, not only is it a point of solution, which means there's one solution, it's independent, it's consistent. Because it's 0, comma, negative 2, the 0's in the x position, and a number's left over, this is also your y-intercept. Example 4, it says 1/5 x minus 1/2 y equal to 1. The second one says negative 4x plus 10y equaling negative 20. So first thing I notice, I have whole numbers in the second one, fraction in the first one. You want to get rid of your fractions, so we're going to use an LCD to get rid of them. So I'm looking at my denominators, 5 and 2. 5 and 2 both go into 10. So I'm multiplying everything by 10 to get rid of your fractions first. So 10 times a fifth makes it 2x. 10 times a half is negative 5y, and 10 times 1 is 10. Slide the second one over. So we got negative 4x plus 10y equaling negative 20. So plus and minus situation here. Plus and minus situation here. So I'm going to multiply by 2 to get this first one to become a 4. I'm going to line it up right underneath to become positive 4x, negative 10y, positive 20. So when we go to add our like terms straight down, negative 4x and positive 4x cancels, gave me 0. Positive 10y, negative 10y cancels, gives you 0. Negative 20, positive 20 cancels, giving you 0. So we ended up with 0 equaling 0. The left and right match. When the left and right are equal to each other, that is infinite solutions, which means we are consistent. But because we're infinite, we are dependent, which means we see one graph line. Example 5 says 2y equals negative 3x plus 4. The second one says 20 parentheses 6x plus 5y closed equaling 40 plus 20y. So the first one is not in standard form. The second one has very large numbers. So first then let's tackle the first one. We're going to add the 3x back. So we are in standard form. So we become 3x plus 2y equaling 4. Now the second one. Instead of distributing into the parentheses, when you come to a problem like this, first look at the coefficients. 20 is on the outside, 40 and 20 is on the outside. 20 can go into 40 and 20. So I'm going to divide all the pieces by 20. The parentheses is not touched. So we become 6x plus 5y equals 40 divided by 20 is a 2. 20 and 20 cancel out, leaving you a 1 with a y. So now I'm almost semi to standard form. I'm going to subtract the 1y back. So now we become 6x plus 4y equaling 2. So now I have two equations. Positive and positive, positive and positive. So we need to make one negative and one positive. So I'm already a 6, so I can make that 3 become a negative 6 by multiplying the entire thing by negative 2. And I'm going to line it up. So negative 2 times 3 is negative 6x. Negative 2 times 2 is negative 4y. Negative 2 times 4 is negative 8. We are distributed into the parentheses. When we add straight down, 6x and negative 6x cancels. 4y and negative 4y cancels, leaving you with 0. 2 minus 8 is negative 6. 0 cannot equal negative 6. Because of this, we know we are no solution, which means we are inconsistent but independent. And because we are no solution, that means we are parallel